Hi guys, welcome back to the GCSEMathsPro YouTube channel. In today's live, we'll be walking through the Edexcel November 2022 Paper 3H higher tier. So you can find it linked in the description if you want to have a look at that one. If you want to see the mark scheme, that's also linked there as well. So make sure you have got your scientific calculator with you, not just your phone calculator. Make sure you're using the calculator you will actually have in the actual exam, right? If you haven't already got a calculator, then I have got one linked in my description if you want to buy one. Otherwise, just see if you can borrow one from, if you've got any siblings or anyone else you know that's not going to be using theirs, you can just see if you could borrow theirs. That's also fine. They might possibly sell them in your school as well for a cheaper price than on Amazon. I'm not sure. Just have a look around, but just make sure you have one. That's the most important thing. So let's make a start. Let me know in the live chat if you have any questions and I can go through them in a bit more detail for you. So question 1, we've got make A the subject of the formula P is equal to 3A minus 9. So quite a nice one to start with. We're just moving everything out of the way so that A is left on its own. So I would normally start by adding the 9. You don't technically have to do it in this order, but that's how I would, prefer to do it. So just move that across by adding it. And then the only thing I now need to do is divide by 3 to get just A on its own. So in that case, I'm just literally going to write this and then just put over 3 as a fraction. P plus 9 divided by 3, exactly. Yep, that would be fine. Just leave it like that. You can also, if you wanted to be specific, you could split it up, but I wouldn't bother. There's no point spending more time on it than just that. Question 2. We've got Rob has been asked to divide 120 in the ratio 3 to 5. Here is his working. They've then said that Rob is not correct. Describe what Rob has done wrong. So sometimes what I do, sometimes it's obvious, but sometimes what I do is I work out myself and then compare it to their working. But let's see. So Rob has divided 120 by 3 first to get 40, and then 120 by 5 to get 24. So he's divided it by both parts. Sometimes it's kind of, I guess, hard to figure out, or at least describe what's been done wrong. So what you can do, I think, sometimes is you can always write down, just trying to check the mark scheme, you can always write down what he should have done if you find it hard to kind of exactly describe what was wrong. So effectively, I think the most obvious answer is normally we add them together, don't we, to get 8. So I would just say he should have divided by 8. That's what I would say. By 8. Just kind of like a correction. Yeah. So that's one thing. From the mark scheme, they've said you could say that he should have divided by 8. You can say he should have added the 3 and the 5 first, which would obviously then give you the 8. You can say what he did wrong was that he divided 120 by 3 and by 5 instead of just by 8. You said about fractions, they've said in the mark scheme he did not do it as 120 times 3/8 or times by 5/8, if that's what you mean by fractions. You can say that. He did not add the 2 ratios first. Those are all the kind of the acceptable answers that they've given you. Yeah. So you have to correct him, basically. Yeah. So that's just a nice one marker. We've now got question 3. 200 students choose one language to study. Each student chose one language from French or Spanish or German. Of the 200 students, you've then got a list of things, which I'll go through in a minute. Work out how many boys chose Spanish. So we've got 3 things, French, German, and French, German, and Spanish, but also we've then got split into boys and girls. So the way that I'm thinking of doing this is by doing a 2-way table. You don't necessarily have to lay it out like this, but that's just how I would think to do it. So you can just grab your ruler. It doesn't have to be, doesn't have to look that nice. Let's get a line. So 2-way table. So I would probably put, again, I don't think it matters which columns and which is the row, but I'd probably put, let's say here, French, then what was it, Spanish, then German. And then you have a total column as well, don't you? I need to write a total column. and then I would have boys and girls, and then total again. And then I could just kind of fill in the information. We can read through the information and fill it in until we get to the one that they've actually asked for. That's probably what I would do, just quickly jot down a two-way table, basically. As I said, it doesn't have to look that nice. There we go, something like that. So what have we got? There are 200 students in total, so we could write that in there. That's the total of both, isn't it? And then we've got, okay, so 90 are boys and the rest of the students are girls. So you can put 90 in the total for boys. You can obviously then work out how many girls there are. Oh, 110. 110. Then we've got 70 chose Spanish. So that's the total of the Spanish column. We've then got 60 of the 104 students who chose French are boys. So the 104 is French as a total, and then 60 of them is just the boys, and then 18 girls chose German. So that's what I filled in so far. And then you can figure out what's missing, or what were they asking for, how many boys chose Spanish. So effectively we want to know this one here, don't we? That's the one we're aiming for. And then you can just start filling in things that are missing. So for example, I know that I could work out how many girls chose French. That's 44, isn't it? And then do you see how then it leaves me with this just one gap here for the total girls. So we can add together the 44 and the 18 and take that away from 110, which gives me, I think, 48. And then do you see how I'm like slowly piecing it together, slowly trying to get towards that? There's obviously one missing here, which I could work out. So the 200 minus basically 174, isn't it? That should be 26. And then I can work out this, and then, oh, you could probably just work that one out straight away, actually. Don't even need to do that, do we? Work this one out straight away, because you've got 70 as your total minus 48. You don't necessarily have to fill out the whole table if you can get to the answer straight away. Obviously, if you can fill out the table, then that's great. So what would that be? That's 26, just in case you want to see the whole table. That's 26, and obviously then this one would be 8. But either way, yeah, you can lay it out like this if you want. Like I said, you don't have to, but I feel like it just helps you kind of visualize it a bit more. When I read this initially, I thought it was going to be a three circle Venn diagram because of the French, German and Spanish, but then because they then split it into girls and boys as well, that's when I realized actually a two-way table with, you know, the two categories is going to be better, the languages and then the genders. So the answer should be 22. That's 3 marks you can see here. 22. So however you got to that, as long as you got 22, then that should be fine. Now I've seen a lot for paper 3, there's normally kind of at the start some kind of, whether it's volume, whether it's surface area, but some kind of 3D shape, but actually when there's a context. So see here we've got like kind of like a storyline behind it as well. That's quite common. So Karina has 4 tanks on her tractor. Each tank is a cylinder with diameter 80 centimeters, so just be careful, that is the diameter, not just the radius, and height 160 centimeters. The 4 tanks are to be filled completely with a mixture of fertilizer and water. The fertilizer has to be mixed with water in the ratio of 1 to 100 by volume. So that's, I just like to put the initials personally, fertilizer to water. Karina has 32 litres of fertilizer, and then they've given you the conversion. Sometimes they don't give you this, so it's probably quite good to know what it is. 1 litre is 1,000 centimetres cubed. Has Karina enough fertilizer for the 4 tanks? So it's just a load of kind of general maths really, isn't it, I guess. So we're going to work out, I would suggest, the volume of the tank. That's why I was mentioning before that just be careful, because they have given us the diameter deliberately, because obviously we normally work with radius, don't we? So just be careful that you would have to swap it for the radius, which is just half. So the volume of a cylinder is obviously pi r squared, as we said, the radius, so pi times 40 squared, times by the height, which is 160. So I would work that out. Let me grab my calculator. So you've got 40 squared, doesn't really matter which order you times it in. Oh, if it lets me write times, that'd be great. Times 160. Now I'd probably just leave it in terms of pi, because otherwise, if I do that, then yeah, that's not great, is it? I'm just going to leave it in terms of pi because this isn't the final answer yet. So what's that? 256,000 pi. 1,000 pi. Now, also, don't forget, though, that that is only one tank, isn't it? Here, there's 4 tanks. So we would have to just take that and times it by 4, wouldn't we? So that's fairly straightforward, but it's just not forgetting any of those details, isn't it? So take your answer, times it by 4. Now, they haven't given it to us in terms of pi this time, so I guess I might just write the whole thing out. Or you could just times the 256,000 by 4 if you wanted, and then chuck a pi on the end. So what have we got here? 3216990. Try not to get rid of any of the decimals just because it's not the end of the question yet, is it? So 0.877. It's not too bad, that number. Okay, so that's the volume of the 4 tanks. Now, I guess we can look at our ratio, can't we? Therefore, how much fertilizer would we need to fill this? So we need to split, or well, basically share out the ratio, which is kind of just what we've just been seeing in the other question, wasn't it? How do I share out a ratio? I obviously add them together. So this answer I would have to divide by 101. Okay, and then the fertilizer is the one side, so that is just the fertilizer, isn't it? This makes 101. So all of this, and it sounds kind of annoying to write it all down, but just so that they can see you're working. Divided by 101, and that should give us 31,851.39, I think it was. I'm going to still keep my answer in my calculator though. I'm not going to round it. I might just write down like a couple of the decimals, but I'm going to keep the answer there. Okay, now that though is in centimeters cubed, isn't it? She's obviously got 32 litres, so you can either convert the litres into centimeters cubed and just compare this number, or take this number, convert it into litres. That's up to you. Obviously they've given you the conversion, so I would just divide this by 1,000, wouldn't I, basically? That's the way around that I'm going to do it, but you could do it the other way around if you want. So I'm going to take my previous answer, obviously with all the decimals, ... divide it by 1,000 to make it into litres. Again, it seems kind of pointless to write it down, I realise that, but you do get the marks for it. So you can see you've got 31.85 litres there. So she's got 32 litres, therefore does she have enough? You have to write obviously yes or no, therefore yes, she does have enough. It's just kind of implied, isn't it? So as long as you made a comparison at the end, then that's fine, and you can say obviously yes. So yeah, nice 4 marks there. Sometimes those are even 5 marks. Okay, so we've done that one. Question 5, we've got triangle ABC and triangle DEF are similar. Work out the length of EF as part A, so that's here. So when you've got similar triangles, you have to obviously find out, first of all, the scale factor, don't you? How much bigger is the second triangle compared to the first triangle? So we need to look at, they should have given you what I call like a pair of matching sides. So in this case, just make sure that it is rotated the correct way. You see how they've shown you that this angle B is the same as angle E, and angle C is the same as angle F. So it is, you know, just copied and pasted, basically. It's not being rotated or reflected or anything. So this side here, I know AC is 5. Do you see how I can compare that to the same side on the other triangle? That's what I'm going to use to find my scale factor, the pair of matching sides. Now you can work out your scale factor by dividing them in whichever order. I normally like to divide the bigger by the smaller. Don't know why, that's just my preference really. You can divide it however you want, as long as you divide it, right? That's the point. I like to do it this way around, I just think it's a bit easier. Obviously that gives me 4. So what I'm saying is the second triangle is 4 times the size of the first triangle, isn't it? And then I would apply that scale factor. Now, because I'm saying it's 4 times the size, and I am going from, obviously in this case, I get a different colour, this side is the one that I'm comparing to EF, isn't it? Because I'm going from small to big, I am going to times it. If you did your scale factor the other way around, then you would probably have to divide to make it bigger. It just depends which way around you've done it. I've done it this way around. So I should get 16. As long as you get 16, then that's fine. Then we've got part B, which is work out the length of AB. Let me just scroll this down a little bit. AB. So then that's just the other side. Do you see how now, though, I'm going the other way around? As in, I'm going from big back down to the small one. So I've got my 22, which is the matching side for AB. So because of the way that I did my scale factor, to go from big to small, I'm now going to have to divide by my scale factor. Okay, you might, if you've done it the other way around, this one you might be timesing. Okay, so this is 5.5. which is another 2 marks. Obviously make sure you write your working to get the method mark. 5.5, there we go. This is an app, this is just like a whiteboard I found on Google. On my laptop basically. I don't know, I don't love it that much, so I might look for a different one to be honest. But yeah, if anyone has any suggestions for whiteboards, let me know, that would be great. But this one is called, what's it called? My View board, I think. My View board, that's what it's called. It's alright, it's fine. It's not like, it's not amazing. I'll type it, hang on. My View board. There, that's the one that I've used. But yeah, if I can find a different one, I might use a different one. Okay, so question 6. On one weekend, the Keddy family is going to do a sports quiz and a music quiz. The probability that the family will win the sports quiz is 0.3. The probability that the family will win the music quiz is 0.35. So just complete the probability tree. Obviously, they have to add up to 1, right? So that would be 0.7 for this one. Each of these kind of 2 branches have to add up to 1. So this one has to also add up to 1, which is 0.65. And the same as this one's also 0.65. So nice, easy 2 marks there. Now we've obviously got part B. Work out the probability that the Keddy family will win both the sports quiz and the music quiz. So which branches would satisfy that? I like to highlight it. So they have to win both. So that's this one and then this one. So it's actually only one set of branches, isn't it? It's only one option. Now, when you're working with probability trees, you have to multiply between the branches. Always multiply between. So that one would just be 0.3 times 0.3, which you could probably figure out yourself, but obviously we can type it into the calculator anyway if we want to. Times 0.3 is, as you can see, 0.09. If you are going to work it out yourself, obviously just be really careful with any of the decimals, but yeah, you might as well use a calculator if you've got it, haven't you? Oh, hang on. Make sure you actually read it properly. 0.35 for the second one, isn't it? Yep, make sure you get it right. 0.3 times 0.35, there we go, because the second one is a different quiz, isn't it? There we go. 0.105 is what you should get. 0.105. We don't have to add anything because there was only that option, wasn't it? It was only win and win. We couldn't do anything else. Okay, so that was it actually for that one. Though they're still giving you 2 marks, that's quite nice. 0.105, there we go. Question 7, we have been asked to change 8,000 centimeters cubed into meters cubed. Now, I guess you might just know the conversion. If you don't know the conversion, the way that I was thinking about it was you have to convert, this is 3D, isn't it? As in a volume, it's 3D. You have to do the conversion, if you don't have it just memorized, you have to do it based on one-dimensional things. So just imagine, you don't have to draw this out, but just trying to over-explain it really. Imagine that this is a cube, that was, yeah. Imagine that's a cube, right? They've chosen 8 for a reason. If I get my calculator and I cube root it to get, imagine just like a side length. So cube root 8,000. Obviously cube root of 8 is 2, so you can see why we've got some version of that. What we're saying is if you imagine it like this, each of these sides are 20 centimeters, aren't they? Because obviously to get volume, you would just do 20 times 20 times 20. Now, the way that I think about it is, okay, if I convert those into meters, because obviously we know more likely how to convert from centimeters to meters in terms of like one dimension. If I had the same, imagine that this is the same cube, that would be, instead of 20 centimeters, it'd be like 0.2 meters, wouldn't it? We should know this conversion here at least. 0.2, 0.2. So to work out obviously the volume of that in, centimeters cubed, I can just do 0.2 times itself 3 times, or just cubed. Now you could write it in the standard form. They have accepted that in the mark scheme, but the decimal is just like this, 0.008. So they will accept the standard form, or they'll accept it like this. Those are the 2 kind of answers that they've given. They haven't mentioned anything about the fraction that came up initially on my calculator. They haven't said that in the mark scheme, so I'd probably go with a decimal rather than going with, you know, the fraction. Okay, so then part B, change a speed of 180 kilometers per hour to meters per second. So how would I think about this? Because you've obviously got kilometers to meters, but you've also got hours to seconds. So I kind of split it into those two. So you might want to maybe convert the kilometers into meters, for example, like meters per hour, and then deal with the seconds, or whichever order you want to do it in. Obviously, we should know that meters to kilometers or kilometers to meters is, there's 1,000 meters in every kilometer. So we want to times this by 1,000, because obviously that's more meters, isn't it, than there are kilometers. So that would be 180 and then 1,000, wouldn't it? Meters per hour. So that's kind of halfway, 180,000 meters per hour. Now I want to look at just the time. So how do I go from hours to seconds? This is where I think, okay, well, there's 60 minutes in an hour and 60 seconds in a minute. So that's 60 times 60 itself, isn't it? But then you have to figure out what you're going to do with that 60 times 60. Because we're going per second, this number is going to be a lot. If you think about it, how many meters could I travel in a second is going to be a much smaller number than an hour, isn't it? So this number needs to get smaller. That's kind of how I logically think about it. So I've got 180,000 meters divided by, my conversion is 60 times 60, isn't it, as I just said. So, I mean, again, you might be able to work that out, but we might as well use the calculator whilst we're here. 60 times 60, 50. Now that's meters per second. So I just split it. I think you could obviously do it in both orders, as in you could do the seconds first, then the meters afterwards if you wanted. But I just like to do it. I don't know, it just makes sense to me to do it that way. So there's your answer, 3 marks for that one. So yeah, just think about it logically, that one. You don't necessarily have to know the conversion, you know, yourself. Okay, question 8. So there are 30 women and 20 men at a gym. The mean height of all 50 people is 167.6 centimeters. That's all of them, right? So the men and the women. Then the mean height of just the men is 182 centimeters. Work out the mean height of just the women. So this is what I'd call a reverse mean situation. So we're going to kind of try and undo the mean, go backwards. So if you think about it, the mean height of all 50 people would be, you know, again, you don't have to write it out like this, but just showing you total heights. That's like all people, so men and women. Normally what you would do is you'd add them all up to get the total, wouldn't you? You'd divide by 50, and that would give you the 167. So I write it out like this because then it shows me kind of how to reverse it. You can see I'm just going to times by 50 to then work out the total heights of all the people. I can't work out the heights individually of, you know, each person, obviously, but I just need to know the total, don't I? So therefore, the total heights of all the people would be those two multiplied, 167.6 times 50. So that's 8,380. 8,380 centimeters, that's the total. Then I would probably do the same with the men. I'm just going to do it here so I've got some more space. So the total height of just the men, this is kind of the explanation, but effectively we're going to reverse it. So you're going to times that one by just 20, right? Because there's only 20 men, isn't it? 182 times 20. Do you see how I'm reversing it? I'm doing the same thing. So 182 times 20 is 3,640. So to find the total height of just the women, I would just subtract these two, wouldn't I? Total height of the women is then just the difference, isn't it? Whatever's different between all of them and just the men. So I would subtract that. So I've got my answer here. I'm just going to use that. So 8380 minus my answer, which was the 3,000 number, 4,740. And now because they have asked us to find the actual mean, I just then need to take the total women and divide that by how many women there are, which was 30, wasn't it? So divide by 30, 158, which if you think about the answer, it does make kind of sense. Like 158 seems logical, doesn't it? So you can always check your answer, go, does that seem like a realistic thing, given that we've actually got a context, a real world context? I feel like something around 150s, 160s would make sense. So yeah, that's what I do for that. Just literally reversing the mean, okay? So just instead of dividing, you're multiplying to find the totals again, and then go from there. Question 9, we've obviously got some standard form now. So the first one is part A, write 6.75 times 10 to the minus 4 as an ordinary number. This is really easy. We're just going to, you can either count the decimal places like this, so just obviously know that you're going this direction because we're getting smaller. So 1, 2, 3, 4, and then you fill in the zeros. Or when it's a negative power, you can just chuck that many zeros in front. It doesn't necessarily work the same for a positive power, but for a negative power it does. That's just how many zeros. You see how there's 4 in total? Obviously the decimal place does have to go between the first two though. 0.000675. So that's fairly straightforward. We've now got a more complicated one for part B. So work out 2.56 times 10 to the power 6 times 4.12 times 10 to the minus 3 over 1.6 times 10 to the minus 2. Give your answer in standard form. Now, because this is a calculator question, I'm going to see if I can just literally calculate it. Let's just see if it will let us. Sometimes if the numbers are too big, it doesn't work, but we'll try it. 10 to the 6 times 4.12 times 10 to the minus 3, and then over 1.6 times 10 to the minus 2. Okay, this is the thing. So a lot of the time with the calculator ones, if they get you to do an actual standard form calculation, what will happen is they might give you the answer as an ordinary number, and then you can see here it says give your answer in standard form. So all you then need to do is convert it. So we've got 659,200. So I'll write that down. 200. And then, because we need to have, it's 2 marks, you probably want to write something in the middle to get some kind of working out. So I've got that. And then, can I convert that into standard form? Well, it always has to be a number between 1 and, not 10, but you know what I mean, like 9.9. So my decimal place would have to go here. So then I can just count, well, how many times have I moved it? Because it was originally here, wasn't it? 1, 2, 3, 4, 5. Now, because this number originally was much bigger than the standard form version, the standard form is this, you don't need to put the zeros, then it's a positive power. So what did I say? 5, right? 1, 2, 3, 4, 5. Yes. So it's a positive power, not like the one at the start, not like part A, which was a negative power. This one is a positive power because the 6.5 has to then get bigger to go back to its ordinary number, doesn't it? That's a positive one. So make sure you do write something down in the middle, because otherwise they are looking for a method mark there, which I know is kind of hard because you have typed it into your calculator. But I just wrote that down. You could even write down, like if you just put this bit in your calculator, you could write that down as your kind of interim method mark if you wanted to. It's up to you. But just make sure you write something. Don't just write the answer, okay? Because otherwise they won't give you the 2 marks. Okay, question 10. Peter has to subtract x squared minus 2x minus 4 from x squared plus 3x plus 5. Okay, so it's the other way around, isn't it? This is the one that he's taking away. Here is his working, so you can see, yeah, he swapped them around. Explain what is wrong with Peter's working. It's odd that they've given us 2 of these where we've had to explain what's wrong. I feel like that's strange in one paper, but anyway. What has he done then? Again, you could work it out in this space here yourself and then compare your answers. But effectively, what he's done is, so he has subtracted, this is fine, isn't it? This bit's fine. He's subtracted that. But do you see how the 2x and also the 4 would become positives? They should be plus, because you're subtracting minus 2x, which is a double negative. You're subtracting minus 4, again, a double negative. So that's the problem there, is he hasn't subtracted the last 2 terms. So let's see, the way that you could word it is, again, you can, instead of saying what's wrong, you could say what it should be. So he should have, I would probably go with, he should have added 2x and 4. That's what he should have done. You can also say he should have done, you could write it like this, minus 2x and minus 4. That's the same thing, isn't it? You could look at this line, like this line to this line, and say, well, it's actually 3x plus 2x, so that's 5x, and it's actually 5 plus 4, which is 9, or so on, like that. You can correct it if you find that's helpful. You could say 2 negatives make a positive, which he hasn't accounted for, something like that. But yeah, it's just referring to the fact that the double negative is what we're referring to, isn't it? Question 11. X and y are integers such that we've got x is between 3 and 8, y is between 4 and 10, but when you add them together, it makes 14. Find possible values of x. Okay, so just possible values of x then, basically. Find all the possible values. Okay, so you have to write them all down. Now, you have to consider that obviously you'd have to be able to add them to make 14, so it's not just anything between 3 and 8. You'd have to see if any of those would be too small. You see what I mean? So technically this one here, let's say, technically just looking at that inequality, it could be 4, it could be 5, it could be 6, it could be 7. However, do all of those work with the y? Now the y could be 5, 6, 7, 8, or 9. And then when you add them, it has to make 14. So you just double check. So for example, if I got 4 for x and I added 9, if I added the biggest number, do you see how that would make 13? That would be too small, wouldn't it? And obviously if I added any of the other numbers of y, it would then be even smaller than 13. So you can't use 4. If I get 5 and I add 9, the biggest number, that would make 14, wouldn't it? So that is a possibility. It's not obviously a possibility in all cases, but they've said possible values. So that is a possibility, yes. So 5 is okay. 6, how would I make, like, out of this next list of y values, could I still make 14? Yeah, I could add 8. That would make 14, wouldn't it? Again, there's a possible scenario there. And 7 plus 7 obviously makes 14. So do you see how, in this case, the possible values of x are just 5, 6, and 7? You can't use the 4. The 4 is too small in all cases. Okay, so I guess it's just a bit of trial and error in that sense. Question 12, I see this a lot on paper 2 or paper 3, is to do with error intervals. So Martin used his calculator to work out the value of a number p. He wrote down the first 2 digits of the answer on his calculator. He wrote down 1.2. Complete the error interval for p. Now this is a scenario. With error intervals, you have 2 possible kind of scenarios. One, which is where it says it's rounded, so it's like rounded to the nearest whole number, or rounded to 2 decimal places, or 2 significant figures, whatever it is, it's rounded to something. In that case, it works exactly the same as upper and lower bounds, so you do a little bit less and then a little bit more. In this case, you've got the other scenario, which we actually call, they've not used the word here, but it's the same scenario, truncating, or they've truncated it. Sometimes they use this word as well, they've truncated the number. What that means is they've looked at, in this case, the first 2 digits, and then cut off whatever came after it. So it doesn't matter if you would have rounded it up or rounded it down, they've just cut it off. They've just chopped it off. So we don't know if it was a 0 afterwards, or it could have been a 9. It could have been. They've just cut it. They've just gone after 2 digits and ignored the rest. That's truncating. Now, in this context of using a calculator, that's what he's done, because he's just looked at the 1 and the 2, and after that he's ignored whatever came after it. He hasn't rounded anything, has he? So if you get this scenario where it's either they've said truncate, sometimes they say the word, or it's like a calculated display one like this, the smallest one is always just the number they've given you, because they've definitely seen a 1 and a 2. So it's not anything less than that, because he's read that off his calculator, hasn't he? There's definitely 1.2. That's the smallest. Maybe it was 1.2000 from there, I don't know. That's the smallest it could be. Now the highest it could be is technically 1.29999 recurring. But do you see how the inequality symbol for the biggest value doesn't equal to that? So that's why you would put 1.3. Now I know that in the calculator it doesn't say 1.3, but what we're saying is it could be anything slightly less than 1.3, which would then be 1.299999999 to infinity. So that's what you would put. So just be aware of error intervals. It's a really easy question, but you have got two scenarios. It's either some kind of rounding scenario, which yes, a little bit less, a little bit more. That's what you'd go with. Same as upper and lower bounds. Or you've got the truncated scenario like this, where it's the number they give you is the smallest number, and then the biggest number is technically like one above, I guess, in that case. The one being one above the two, which is 1.3. So just be careful of that. But you do get 2 marks in terms of 1 for each number, I'm pretty sure. So even if you weren't sure about the big number, you could definitely get the mark for the smallest number. Just put the one that they've given you to start with. Okay, so yeah, error intervals I feel like is very common for paper 2 or paper 3. Question 13, we have Chen has this information about the time that it took an operator at a call center to answer each of 90 calls. So he's put it already into a cumulative frequency table. Chen draws this cumulative frequency graph for the information in the table. We need to write down, again, I don't know if you can see that, hang on. See if you can see the question. Yeah, you can just about see the question. Write down 2 different things that are wrong with the graph. Another question where they've said what is wrong with it, so really strange. I think it's November. I feel like the November papers feel a little bit different for some reason. So let's see what's wrong with the cumulative frequency graph. They've given us the table as well, so sometimes I like to see the coordinates. Now you can see in this case, he's only used like half of the graph paper, so I'm already thinking something's wrong with that. So I like to check the coordinates. Here is 5, this one is then 10, 15. What he's clearly done, he's used the midpoints, hasn't he? This is why you don't use the midpoints for cumulative frequency, because can you see how you'd only fill up half of the graph? It's meant to go up to 50, isn't it? It doesn't. So that's one thing. One thing is that, I'll write it over here so you can see it. He's used the midpoints or the x coordinates or whatever you want to call it. The x-axis. That's one thing. What else have we got? Maybe we can check the cumulative frequency coordinates because it is a nice curve. He has done the curve correctly. That's quite nice. So let's check. That does look like it's at 4. Then we've got 25. Yeah, that would say that's 25. Then we've got, it's meant to be 70. Yeah, 70. Then we've got 88. Yeah, okay, so the y coordinates are all fine. The other thing I think I would probably go with, he has labeled it cumulative frequency, isn't it? But he hasn't labeled the x-axis. So I think that's probably the other thing that's missing, isn't it? He hasn't labeled the x-axis. That's probably what I would put. Midpoint plotting only for cumulative, yeah. So the plotting the midpoint is only for frequency polygons. That's the only scenario basically when you plot the midpoint. Frequency polygons don't come up as often as cumulative frequency. But yeah, the midpoint is just for a frequency polygon. It's difficult because they obviously both derive from a frequency table, so it seems kind of similar, but it is a completely different topic. So yeah, you're not supposed to use the midpoints. In terms of cumulative frequency, you're supposed to use these ones, like the right-hand side values, which is why it's meant to go up to 50 in this case. So what was my other one? I was saying that he hasn't labeled the x-axis. That's probably what I would say. No label on x-axis. So he's used the midpoints and he hasn't labeled the x-axis. Those are kind of the only things they've said. Like those, as long as you've written some version of those 2 answers, that's the only answers they've offered. But you obviously would probably write it differently to me. And that was 2 marks, obviously 1 mark for each reason. Question 14. So we've now got some algebra. I feel like because obviously your Edexcel paper 1 didn't really have many indices, did it? So I feel like they could bring it up in paper 2, paper 3. They still need to test it, don't they? And this is how they would do it, is with algebra, because obviously then you can't type it into your calculator. So simplify fully, 3x to the power 5, y to the power 6, and then all of that is to the power 4. So I just break this down into 3 pieces, the 3, the x, and then the y. All of them are to the power 4. This is one with the brackets, so you have to multiply the powers, but the thing that people get confused about is the 3, I think, at the start, because either they don't do anything with it, which you do need to do something with it because it's still in that bracket, isn't it? Or they multiply 3 by 4, which is also incorrect because 3 is just a whole number, it's not the power. We're only meant to be multiplying the powers. So you can imagine it like this if you want. Technically 3 currently is 3 to the power of 1, isn't it? So if I went through and multiplied the powers, do you see how that would give me 3 to the power of 4? I'm not multiplying 3 by 4, I'm multiplying the power of 1 by 4. Obviously then the 4 and the 5 is 20, and then that's 24. However, the last thing is then that the 3 to the power of 4, you obviously can actually work that out. Now you might just know what that is. If you don't, obviously work it out as an actual number, don't just leave it as a power. It's 81. So you should get 81, x to the power 20, y to the power 24. You just deal with them each column of that separately, the 3, the x, the y. Okay, so that should be what you should get for part A. There's a lot of expanding triple brackets in papers 2 and 3, which I think is quite nice. It's just quite an easy one to know what to do with. So I always recommend to expand the first 2, or just, well, you can technically pick any of the brackets, but just pick 2 at a time. I normally just do it in order. So let's expand just the double brackets, the first 2, x plus 2, x minus 3, and then I'll bring back the third one afterwards. So that should give me x squared minus 3x plus 2x minus 6. Obviously simplify that first before you then multiply it by the other one. So I'm going to write it down here just to give myself some space. That would give me what, minus x minus 6. Just be really careful of any negatives. And then I'll bring this one back. Now some people multiply this in a different order. I like to do it like this. So each of these 3 terms I'm going to multiply by both of the terms in the second bracket. Some people do it a different way, that's fine. So I get x cubed, and then I'll do the x squared again, but this time obviously by the 4. So that's 4x squared, and then I'll move on because I've done the x squared now. Then I'll move on to the next one, which is minus x, negative x, times by x. So that's minus x squared, and then minus x times 4, minus 4x. And then lastly, you get a different colour, just so you can see, the 6, or the minus 6. So minus 6 times x, minus 6x, and then finally, there should be 6 terms, basically. Minus 24. Now, the reason why I like to do it in this order is because can you see now that all of my like terms, when I go to simplify it, are next to each other? You don't have to do it like that. It's obviously not that important, but I just quite like that. I think it makes it easier. So obviously we get the x cubed, that doesn't ever have a like term. The x squareds we can actually combine, so that's what, plus 3x squared. And then the x is minus 10x, and then just the minus 24 at the end. Yeah. That's how I do it. You might have multiplied it the other way around, that's fine. As long as we've got the same answer at the end, it really doesn't matter. You get a nice 3 marks for that. So question 15, we've got a pet shop has 7 guppy fish, 13 tetra fish, and 5 angel fish. David is going to choose one of the following combinations of fish. So a guppy fish and an angel fish, tetra and angel, guppy, tetra, and an angel. So one of those 3. Show that there are 555 different ways for David to choose his fish. This is called, I call it product rule for counting. You might call it like combination, something like that, but that's the topic, isn't it? So I just went through and worked out all of these 3 options separately. So because it's product rule, it means you multiply, doesn't it? So in terms of the guppy fish and the angel fish, that is 7 times 5, which is just 35. Then the other option, tetra by the angel, 65, and then the last one is all 3, so 7 times 13 times 5. That one I probably would just work out in the calculator. 7 times 13 times 5, 455. You can see we are getting somewhere close. And then because it's one of these, I just add them together, and hopefully you can see that that makes 100, so that's going to make the 555. So that's basically all I did, just multiply them all separately and then add them up, and then obviously if you've got the same number then you know that you're right, aren't you? So yeah, that's it for that one. 555, we've obviously got the same as them. Question 16, we've got circle theorems. I'm pretty sure you didn't get circle theorems in your paper 1, so I feel like that's definitely going to come up at some point, isn't it? So we've got here ABDE is a cyclic quadrilateral. So they've actually told you that, that's helpful information. They've said that ABC and EDC are straight lines, which you can kind of see, and then they've obviously given us this angle here. Given that the size of angle EAB, so this top one, to the size of angle BCD, this one, is 2 to 1. Now, you don't have to do this, but I like to label it with algebra. So like, for example, this would be 2x, and this would just be 1x, wouldn't it? Or just x in that case. So I just do that. That's just my personal preference. Work out the size of angle BCD. Okay, so that's the one we actually want to find, is the x. So given that we've only been told one angle, as in the 60, you're going to have to start there, aren't you, basically? So what I was thinking is, they've told us ABC is a straight line, so we could work out ABD. They haven't said to give any reasons this time, just double check if they do. So I do obviously 180 minus 60. I know you probably know what that is, but we might as well write it down just for the working. So that's 120. And then what I thought about was the fact that they've told me I've got a cyclic quadrilateral. So what is the circle theorem that relates to that? The opposite angles in a cyclic quadrilateral add up to 180. So this one here, and E and B basically are opposite, aren't they? So you'd have to minus it again. I know we know the answer, but just write it for the working out. So that's 60. And then, this is the bit that I think I got a bit stuck on, but try and sometimes, I say like zoom out, try and look at the bigger picture. Try not to just focus on this shape or just this shape. Try and look at the whole thing. We've got a big triangle, ACE. That thing as a whole is a triangle, isn't it? And you see how I've got 60 degrees for one angle, I've got 2x for the other, and x for the final one. So I've technically got enough information for all three angles. So obviously I know that 60 plus 2x plus 3x, plus x, sorry, which makes 3x, should make 180 because it's a triangle. So that's 60 plus 3x, as I said, is 180. And then I can just solve that. Or you might have shared it out differently. That's fine. If you just took away 60 from 180 and then shared out the ratio, that's also fine. But I don't know, I prefer algebra personally. So what's that? 120 divided by 3 gives us 40. And then we were just looking for x, weren't we? That's the one we were just looking for. So sometimes you're looking for the one that is 2x. So just double check. Do I need to like double it again or not? In this case, we didn't. So either way, you should get 40. If you've got 40, I'm assuming then they'll give you all the method marks as well. Even if you did it differently to me, that's fine. So yeah, that wasn't too bad for a circle theorem one, I don't think. All right, now we've got what looks like ratio, percentages, fractions. So there are 4 boxes on a shelf, A, B, C, and D. The total weight of A and B is 3 times the total weight of C and D. Okay, right. The weight of A is 2/3 the weight of B, and then the weight of C is 75% of the weight of D. So that's a lot to take in. We'll read through it again. Effectively, what we want to look for is we're finding the ratio of A to B to C to D. Okay. All right, how would we tackle this? Again, I feel like there's different ways to do it. I would lean towards making equations. You might lean towards just creating ratios from the beginning. I don't really like ratios, so I tend to try and avoid it until the end. So let's see, what I'm thinking is the total weight of A and B, so A plus B is how I would write it, is 3 times. So wherever it says is, that's where you put the equals, just so you don't get the 3 on the wrong side of the equation. So then it's 3 times the weight of C, so C plus D, put that in brackets. That's my first equation. I'm just trying to translate the words, like the sentences, into equations, basically. And then let's look at the second sentence. I'm just going to do this for all 3 sentences and see where that helps. All right, so we've got the weight of A is, so A is, as in equals, 2/3 of B. Okay, and then we've got C is, now you could put 75%, you could put 0.75. I don't know, maybe I'll convert it into 3/4, whatever you want to do. D, so I've got that. Okay, that's kind of where I'm thinking to start. If you wrote that, I'm just checking the mark scheme so you can see how many marks you'd get, because I feel like some of these questions you might only get halfway, which is fine. But writing something is still better than nothing. If you wrote that, it says for giving all 3 relationships in the same form. So whether you did it my way, which is algebra, whether you did just different ratios, that's fine, but you'd get 2 marks for that. Do you see how, and this is I think this is a 4-mark question. So you don't, even if I just wrote those 3 things down, That's already half of the marks. Like, even if I didn't really know where to go after this point, you've already got half the marks. So it's definitely worth writing something down. Now, obviously, we want to link them all. So let's see. Let's see, how could I link them all? I'm thinking like some kind of substitution, isn't it? That's what I'm thinking. Maybe if I sub in these two to the original, that's what I'm thinking. So that could be 2/3 B plus the other B is equal to 3 lots of 3/4 D plus the other D, and then obviously you can, collect the like terms there. So that's like 3/3, that's 5/3, isn't it? You can add this up on your calculator, obviously. Is, what's that? 7/4 times 3, 21/4 D. So you could write that. And then we know that A is 2/3 B, don't we? And we know that C is 3/4 of D. So you can work from there. So this one, because I've used algebra, I guess you'd have to know there's a specific way to convert algebraic equations into ratios. You might want to make them whole numbers first, you might not. I guess that just depends. I guess in this case you'd have to cross multiply, so let's just do that. That'd be 20b is the same as 63d. So then if I know how to convert from an equation into a ratio, this is just something you have to memorize. Sometimes you might have had it in a divide scenario. I just kind of know it like when it's like this, you just swap them, as in b to d would be the 63 to 20. You just swap it. You might know it as a fraction format, that's fine. So I've got a ratio of those two now. And then, do you see how I can bring in A and, well, I'll put C over here, but we'll rewrite it at the end. A is 2/3 B. If B is 63, we can find 2/3 of that, can't we? I think it's 42, but let's just, make sure I'm not completely wrong. 2/3. Yeah, 42. So A would be 42, which then makes it the same scale, doesn't it? And then for C, it's 3/4 of 20, which is 15, isn't it? Now, the only thing I need to do, obviously, is then let me write it in the correct order, because they wanted, can you see that? They wanted A, B, C, D, obviously, in that order. So A to B to C to D, I've got 42, I've got 63, then I've got 15, and then I've got 20. Now, they haven't said in its simplest form. I don't know. I don't think that would simplify anyway. I'm just thinking those ones would divide by 3, but not the 20. So, yeah, I would just leave it like that, personally. That's how I would just leave it. But as I said, you could do it that way with the algebra. You could just create ratios initially and then use the ratios at the end. That's also fine. As long as you got to the same point here, you've got the same answer, then that is fine. But yeah, as I said, I think this is a 4 marker. So even if you only got halfway, if you just wrote out all those relationships, either in ratios or in equations, if you got all 3 relationships correct, that's 2 marks out of 4. So if this is one where you didn't really know how to finish it, that's okay. If there's ever ones where you don't really know what to do initially, just try and write something, even if you're not sure if it will lead you anywhere, because you just never know when you can get those extra method marks. So question 18, shape A is reflected in the line with equation x equals 2 to give shape B. Shape B is reflected in the line with equation x is equal to 6 to give shape C. Describe fully the single transformation from A to C. Yeah, that one's, I guess, a little bit difficult because they haven't showed us, have they? But you could always, they've given you some kind of space almost here. You could almost sketch it if you wanted. I know we don't know where the shapes were originally, but I guess it wouldn't really matter. So let's say you put the axes, and then where x is 2 is, let's say here, and then x is 6 would be like here, wouldn't it? So I'm just going to go with the fact, I'm just going to make this up. Let's imagine that I've got a triangle here. If that was reflected, it would go, I know this is not accurate, but it would go to here, wouldn't it? Let's say there, and then so then that's reflected. Imagine that that's an equal amount of distance, and then it would reflect it again. So it's basically just going all the way here, isn't it? That's what you could almost draw that out if you wanted. So it's only moving along the x-axis. That's the first thing, isn't it? There's no kind of y-axis scenario. So I'm thinking it's going to be a translation, isn't it? That's the first thing we could say, a translation. And then we need to figure out the distance. How far is it translated by? And I think because this is 2 and this is 4, because we obviously don't know where the original shape was, do we? That's not 4, that's 6, but what I was thinking is the distance is 4. There's a distance of 4 there, and then it would kind of be like half on each side, wouldn't it? Because obviously it's not on the line necessarily. So I would say, I think I would just double that to get like an equal mirror on each side, if that makes sense. Kind of like 4 here, 4 here, that makes 8, doesn't it? So translation, you could say by 8, as long as you say the x-axis, or you can put it in a column vector if you want, like this. On the x-axis, the y-axis hasn't really changed. But that's probably what I would do for that one, but definitely a translation. You can see it's just moving across, isn't it? Question 19, so we've got, look, by the looks of it, some kind of probability again. There are only blue counters, red counters, and green counters in a box. The probability that a counter taken at random from the box will be blue is 0.4. And then the ratio of the number of red to green counters is 7 to 8. So I'm going to put red here, green here. I just like to look at it. It's a little bit easier to kind of refer back to then, isn't it? So Samina takes at random a counter from the box. She records its colour, puts it back. So she does replace it. Samina does this a total of 50 times. Work out an estimate for the number of times she takes a green counter. So we need to first know the probability of the green counter, and then we can apply it to the 50 times. So we've got, obviously, all probabilities add up to 1. So the chance of getting blue, green, or red is 100%, isn't it? It's 1, because there's only those colours. So what I would do is I would take away, you can make this into percentages if you prefer to not use decimals, but I don't know, it's a calculator question, so it's not too bad. So that's the probability there. That would be the probability of red or green, wouldn't it? Because we've taken away the blue, so what's left is red or green. And then I would share out this ratio. As I said, if you want to use 100%, and just so you've got bigger numbers rather than decimals, that's fine. And then you can split out 60 rather than just 0.6. But as I said, we have a calculator, so it's not too bad. So we've just sharing out more ratios, aren't we? We've already done this twice. So we obviously add it up to make 15. I'm just going to use the 0.6 divided by 15. So one part of my ratio is 0.4. Let me just write that down so that I've got the method marks. That's one part of my ratio, isn't it? However, what were we looking for? We're looking for green, so I don't really need to care about the red. The green side is 8 parts, so I would times that by 8, which gives me 0.32. So as long as you've got 0.32 by some method, then that's fine. Or you might have 32%, same thing. So that's the probability of just green, isn't it? Obviously the red is then what's left, but we don't really need to know the red. So then she's done this 50 times, so the probability of getting green is the same every time because she's obviously put the counter back, so nothing has changed. So then we just want to times that by 50. So effectively, what is 32% of 50? 16. So that's it, 16. Yeah, 3 marks. So yeah, that one's quite a nice one, I think. As long as I feel like I've seen a different one that was very much the same, but obviously just slightly different context, slightly different numbers. But it was I think it was one with purple in it. So, and you had to get rid of the purple first and then share out the rest between the ratios. So that's, I guess, a question that has been repeated, which is nice. So now this one I think is a little bit trickier. Anything to do with congruent triangles I think is a little bit tricky. So we've got here the diagram shows triangle ADE as obviously as a whole. Then they've said that AE is the same as DE, so this line here or this side here is the same as that side. And then they've given us a ratio for this base bit. AB to BC to CD is 1 to 2 to 1, so it's split like that. Prove that triangle ACE is congruent to triangle DBE. So what I'm going to maybe do is just quickly draw them out. There's so many lines, isn't there? A to C to E. Just let me do this really quick with different colours, just so we can visualize it a little bit better. So that one, and then if I get a different color line, is then you see the one that kind of overlaps from the right side. This one here. Not done that very well, but you can see what I mean. There. Let's see if I can move that. No? Okay. Right, so those are the two triangles. Obviously, when we're proving that two triangles are congruent, we're looking for some version of, we need three things that are the same, don't we? So it could be side, 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 could be side, angle, side, it could be an angle, a side, an angle. It has to be in that order, right? Of the way you look at it. I think you can also do angle, angle, side, and technically there's a right angle one, but here we don't have a right angle, so I'm going to ignore that one. So we need to prove like one of these. The most obvious one, which you can get literally 1 mark for writing, which seems pointless because they've also written it, is that they both share a side in common. They've told us that AE is the same as DE, isn't it? That's part of each of those triangles. I would literally write that, even though they've already written it themselves. You have to give a reason why, but the reason why is because it's given. They've told us that. You know, just write that. They've told us in the question. You can say the word given, that's fine. That's our reason. So that literally, if you just wrote that, this is only a 3-mark question. If you wrote that, that's already 1 mark. Right? Which seems kind of stupid, but anyway. So we've got a side, so I'm thinking, okay, we've got a side. What else can we prove is the same? They've obviously given us this ratio for some reason, so maybe we could do something with that. That's obviously to do with the sides as well, isn't it? So I'm looking at these sides. Think about the ratio. So A to C, I know it's not literally 3 centimeters, but it adds up to 3 parts, doesn't it? But also B to D also adds up to 3 parts. And that's the base of both triangles, isn't it? So those are, if their ratios are the same, then they must be the same in whatever actual centimeters they are. So I would probably write that for the next one. How could we write that? AB plus BC is the same as BC plus CD, isn't it? You could write it like that. So therefore, that means that AC, which is the actual base of one of the triangles, is the same as BD, which is the actual base of the other triangle, isn't it? And you could say like, the reason is because of the ratio. That's effectively the reason in this case, isn't it? So I've currently got 2 sides. So out of this, I'm looking at the first 2. Can I prove all 3 sides are the same? Or can I prove that I've got an angle, but it has to be the angle between them? So you see how I've got AE and then AC, it would have to be this angle here. So can I prove maybe that angle is the same as this angle? That's now what I'm thinking. If you've got these 2, by the way, that's already 2 marks out of 3 anyway. As long as you've got, as long as you've written the reasoning, then that's fine. That's 2 marks. So I think I'm going to look at these angles here and get my green, this angle and this angle. Those must be the same as each other because effectively we've got an isosceles triangle. If you look at the whole triangle ADE, I know that AE and DE are the same. They told me that, didn't they? So that makes it an isosceles triangle as a whole, as the big triangle. So therefore they must, with the isosceles triangles, the base angles are equal. So that's my third thing. That's what I'm going to say. So I'll just write it down here. So, I need to see the angles, don't I? What was it? DAE, or if you write it the other way around, that's fine. So angle D to A, well, let me actually include just my, the part of the triangle. It's C to A to E, isn't it? In that triangle on the left is equal to angle B to D to E, which is the other triangle on the right, because of isosceles triangles. So I would say base angles. You have to say specifically isosceles, otherwise it's obviously not proving anything, is it? Isosceles triangles are equal. And you could say that the triangle, ADE, is obviously isosceles, isn't it? Now, you do have to put a conclusion then. Like, what does that mean? So, therefore, congruent, because, what is going on with my pen? Because of, in this case, I got side angle side, didn't I? Side angle side. Side angle side. If you write, you don't have to write it out as literally side angle side. As long as you put the acronym, you do have to write that though. Okay, so there's three things there that are the same from, different reasons, and therefore it was congruent because of the side angle side rule. And that one was 3 marks. But as I said, you literally just get 1 mark for writing down what they've already written in terms of the two sides are equal. So it's always worth just writing that if that's the scenario. Sometimes I have seen that, yeah. I've seen that a few times. So even if you think it's too obvious, just write it down anyway. You just don't, yeah, it's just worth writing down anything even if you think it's too obvious, you might as well write it down because who knows what's on the mark scheme. Okay, question 21. The equation of a curve is y equals 4x squared minus 56x. The curve has one turning point. By completing the square, show that the coordinates of the turning point are 7 minus 196. You must show all your working. So we're completing the square, basically. I don't think you've seen completing the square in your paper 1, so again, I would assume that will come up very likely in the next paper or paper 3. So completing the square, the only thing is we don't really have this plus c, but that's fine. We don't really need to use that, do we? It does look a bit different. So completing the square, we've got this 4 in front of the x squared, so you do have to factorize out the 4 first. In this case, we're factorizing out of both terms. Normally, I would factorize it out of just these two first terms, because there is normally a plus c, isn't there? In this case, it's, yeah, the same thing, isn't it? You're factorizing out of just those two. So we've got x squared there, and then 56 obviously does divide by 4 as well, which is 14, so minus 14. So I've not even started completing the square yet. I've literally just factorized out the 4. Now I'm going to complete the square. So the 4 is on the outside. Then I do x in my brackets. I copy the same symbol here and I half this number. So that would become 7. That's in the brackets squared. Then you always subtract whatever this number is squared. I know it's minus 7, but if you square minus 7, it becomes positive anyway, doesn't it? So you're going to subtract that either way. And then technically, sometimes you normally have a number on the outside, don't you? But we don't here. Now I'm obviously going to expand the 4, so leave the squared brackets, but just multiply both, like obviously the brackets by 4, and then also this. This is technically minus 49, isn't it? So minus 49 times 4 is still a minus 196, which you can kind of see because we're getting closer to this. So I've completed the square. Then I obviously then need to write down the turning point. If you're not sure how to make it into the turning point, you can see you've got the numbers there, so just copy the turning point. But effectively, it's always the number that's in the brackets with the x is the x coordinate, but you do have to change the symbol, hence why they've got a positive 7. You're not wrong and you're completing the square. You do just have to change the symbol. So that's the x coordinate. And then the y coordinate is the one that's on the outside, but as you can see, you do just take it as it is. So if it's negative, take it as negative. If it's positive, take it as positive. Don't swap the coordinates. So that's it. It's just completing the square basically, and then obviously just copying what they've written in the question. So that was 3 marks. Question 22, we've got algebraic fractions. Again, this is something that I feel like didn't really come up in paper 1, so I would expect some format of this topic to come up later on. So we've got here 2x plus 3 over x minus 5 plus x minus 4 over x plus 5 minus 3 can be written in the form ax plus b over x squared minus 25, where a and b are obviously integers. We need to work out the value of a and b. So we need to basically get to this format, and then we'll obviously find a and b. So you can see, in order to add or subtract, we need to have obviously common denominators. Now, they've also given you a bit of a hint as to what the common denominator is. It's obviously these two multiplied together, isn't it? If you think about it, this is like difference of 2 squares, isn't it? So the first one, the first fraction, I would have to multiply by the missing part of the denominator. It doesn't have the x plus 5, does it? So I'd have to multiply by that. Then I can add it, I'm just going to add it straight to the other one. The other one, x minus 4, doesn't have the x minus 5 in its denominator. Ooh, trying to draw a nice line. And then that would be over the x minus 4x x plus 5, which obviously you can expand. Now we have got this minus 3 though, which technically a whole number you can write it as over 1. So its current denominator is 1, which means it doesn't have either x minus 5 or x plus 5. So you would have to multiply, I don't know if it's subtract, 3 by both. I don't even have enough room, but you can see what I'm doing hopefully. And then that would bring it into the same fraction. So you can do that in multiple steps. I've just written it in one step. Obviously at this point, I'm now going to expand and try and simplify everything. So just be careful of any negatives. Be careful especially of this last bit here. that we're subtracting all of that. So some of those symbols will swap. So the first one, we've got 2x squared plus 10x plus 3x plus 15. Then we've got, this one's just plus, so that's fine. Oh. X squared minus 5x minus 4x, and then that would make plus 20 at the end. So again, just double check. This one, what I would probably do is leave the minus 3 there and expand just the double brackets first, and then you can times everything by 3. So what's that? Oh, that's just the difference to squares one, isn't it? So we know, based on the denominator and also just generally, that would expand to x squared minus 25, because obviously the middle terms would just cancel out anyway. And all of this is, I'm going to expand the denominator because they have. If they didn't anyway, I normally wouldn't, but because they have, I'm just going to copy that. Now, obviously, I guess the last thing, let's just multiply that in 1, shall we? Just so I don't have to write a whole other thing. So it would become minus 3x squared, but as I said, be careful because you've got minus 3 times by minus 25. So not only is it obviously 3 times 25, it would also become a positive. So just be really careful of that because you're subtracting a negative, which makes it positive. Okay, now we can collect our like terms. Let's see what we've got. 2x squared plus x squared is 3x squared minus 3x squared. You can see they cancel, and that makes sense because the answer doesn't have any x squareds in it. So those all cancel anyway. Then the x's, we've got 10 plus 3 is 13, minus 5 is 8, minus 4 is 4x. So yeah, we should get 4x there. Let me write that one. You can obviously simplify those, together as well if you want. And then the last one, we've got 15 plus 20, which is 35, plus 75, which is what, 110? Is that right? Yeah, 110. Obviously use your calculator if you want to. So we've got this. It doesn't simplify because the denominator is just there, isn't it? There's nothing to simplify. So they've then said, what is A and B? Well, 4 and then 110, isn't it? So I'll come down here. You just have to fill in this little bit here for 110. That's it. Yeah, it's long. Only 3 marks really. Kind of long for 3 marks, I feel like. But as long as you're okay with, just being really careful with all the positives and negatives, that's kind of the biggest issue, I think, where you could easily go wrong. Then it's not too difficult. Okay, 23, we've got graph transformations again, something that hasn't come up yet, so definitely look out for that. Part A, they've given us that the graph of y equals f of x is shown, so it's obviously some kind of cubic graph. On the grid above, sketch the graph of y equals f of x plus 2. You literally just have to have this memorized, right? That's it. So when it's in the brackets, we've got plus 2. It's obviously an x-axis translation. However, the x-axis is always something wrong with it, isn't it? It's always the wrong way around. So actually, I'm going to move everything not to the right, but to the left. You just have to memorize that. However you want to memorize it, it's fine. Now, because it's a sketch, I'm just going to pick some kind of coordinates that are quite obvious. So like the one where it crosses -1, that would go to -3. Maybe this one here would go to -2. Do you know what I mean? This turning point, I guess, is kind of halfway here, isn't it? So 1, 2, so that'd be here. And then maybe, yeah, that's actually not. Oh, well, I guess actually, rather than the turning point, you could just do those bits where it crosses, couldn't it? Because it goes at 1, so that's like -1 and then 2, which is 0. So that would just go, slightly below there, wouldn't it? And then how far does it come? It stays within there, so about here. And then this one, 1, 2, so about here. It's just a sketch, but as long as they can clearly see like some solid coordinates. I obviously can't draw it very well digitally, but hopefully, oh, that was really bad. Hopefully you'll obviously be able to draw a much better job with pencil. Do it with pencil, so if it goes wrong, you can rub it out. Okay, something like that, obviously not as wobbly. Yeah, it should be something like that. Only 1 mark, but if you can just memorize those things, then it's quite an easy 1 mark. We have got a part B, so now we've got obviously a different graph. So we've got graph A, which looks like the black one, and then graph B is kind of like this grey colour. So on this grid, graph A has been reflected to give graph B. The equation of graph A is y equals g of x, write down the equation of B. So it's obviously been reflected, but where? It's obviously reflected here, isn't it? I would say, along the x-axis. Now, how do we then write that? It's kind of the reverse, isn't it? How do we then translate that back into the equation of a graph transformation. Obviously, a reflection is always a negative, but where do we put the negative? Is it with the x or is it on the outside? So which coordinates has it affected? Because it was a reflection in the x-axis, it's only affected the y coordinates, hasn't it? All the x coordinates are the same, aren't they? It's just the y has now gone from above to below or vice versa. So because it's affected the y coordinates, it's going to be on the outside. If it's affected the x coordinates, it will be a negative in the brackets. Yeah, minus g, exactly. So you would just write that. Also one other mark. So there's that one, 2 marks for the graph transformations. Question 24, we've obviously got vectors. Again, something that hasn't come up yet, so definitely one I think they would want to ask something about. So we've got CDEF is a quadrilateral, as you can see. They've given us some vectors which they've already labelled. If they haven't already labelled it, you can obviously draw it on yourself. They've then said the point P is such that CEP is a straight line, and then the distance C to E is the same as E to P. So P is obviously somewhere over here, isn't it? So I would probably draw that myself. Let me make sure it's black again. So C to E, it doesn't have to be super accurate, but just C to E, and then like roughly about the same distance, just visually so you can see. Roughly something like that. P would be over here then, wouldn't it? Okay, use a vector method to prove that CF is parallel to DP. So I'm also going to draw DP, because that's not drawn anyway, is it? So parallel ones I find are quite nice actually, or if it says prove it's on a straight line, that's basically the same question. What we need to do is find the vector for both of those, CF and DP, and then hopefully we'll obviously find out that one of them is just a bigger version or a smaller version of the other. So that's all we're going to do. So what I'm actually focusing on is finding those vectors. Obviously C to F is kind of the easiest one to start with, isn't it? Just go all the way around here because I've got all those vectors. So you might as well write that one down to start with. C to F would be 2a minus b minus a. I'm going to write that just so I can get the method. And then you see that would just be a minus b. So I'm assuming that would give you probably 1 mark to start with. Let's see. Yeah, you get a mark for just writing that, which I think is, even if you didn't really know what to do with it, it's quite nice. Okay, D to P, how do we get there? Ideally, we would obviously, I guess, go down to E and then across to P. So I'm going to be looking at this CE, EP lines. So I can definitely work out CE, can't I? That would be another mark. So C to E would just be 2a minus b, wouldn't it? Now, obviously, this is the bit where you've got to try and put 2 and 2 together, because it's not really like we can follow lines to get to P. It's more the fact that they told us CE is the same, not only length, but therefore the same vector, because they're on a straight line, as EP. So if CE is 2a minus b, then EP is also the same. Like that's just how you'd have to work out EP, is by working out CE and then realizing that because it's on a straight line and they've said that it's the same length, that means it's the exact same vector, identical vector. So I've now got EP, so then lastly, D to P, I can go, obviously minus B, minus B, to get to E, and then along EP in the correct direction, plus a, minus B. And then if I simplify that, yeah, that works, doesn't it? That would give me 2a minus 2b. So these are the ones we're comparing. This one and this one. Now that I've found them both, how many marks would that give you? That'd probably give you 3 marks just for finding it. Obviously the final mark is then to explain why they're parallel, and that's what I was saying. Parallel vectors is where one is a multiple of the other. So you can clearly see that DP is just twice the size of CF, isn't it? It's just twice the size. This one's kind of more obvious. So I would probably write it something like this. DP is, you remember when I said where in your head where you say the word is where you put the equals, and then twice the size of CF. So that shows that they're multiples. Just, you can even write they are multiples, obviously, if you want to, but I'd probably write it like this. Therefore, that makes them parallel, because they're multiples. They have to be multiples to be parallel. So however you want to write your conclusion, just kind of show that one is twice the size of the other, or you could do it obviously the other way around. You could say CF is half the size of DP. That's also fine, as long as they're multiples. Then it means they're parallel. So that one was quite a nice one, I think, as long as you're happy with parallel proof and also straight line proof, because when it's a straight line, you first of all prove that they're parallel, which is the same, and then normally obviously they would have one point in common. So you're like, well, it must overlap because they have the same point in common. Obviously not in this case, but if you do have a straight line, it's just prove they're parallel and then add on the additional point that they share something in common. So they must obviously not only be parallel, but actually overlapping, which creates a straight line. So I think that's quite nice compared to some of the other vector questions. Okay, I think we have just 2 more left now. Yeah, 2 more left. This one I think 25 is 5 marker. So the pyramid P is formed from 2 parts made of different materials. So you can see the top and the bottom. The top part of P has a mass of 92.8 grams and is made from material with a density of 2.9 grams per centimeter cubed. The bottom part of P has a mass of 972.8 grams. And the average density of P is 4.7 grams per centimeter cubed. Okay, so we've got the mass of both, we've got the density of both. Calculate the volume of the top part of P as a percentage of the total volume of P, not just of the base, of the total volume of P. So we're finding volume. This is the one that you do need to know the formula for, or at least the formula triangle. Mass goes at the top, density is mass over volume. Obviously in this case we're looking for volume, so that'd be mass divided by density, wouldn't it? So we need to first work out the volume of the top part, then the volume of all of it, and then make it into like a percentage. So the volume of the top part, as we said, is mass over density. So we can see we've got 92.8 over 2.9. We can just do that straight away. Obviously you will want your calculator for this. 2.9, so that's 32. Okay, luckily it's a nice number. 32 centimeters cubed. Now we can obviously then work out the volume of the bottom bit, but just don't forget that they don't want those as a percentage, they want the total volume. So the volume of the bottom bit, 972 grams over 4.7 density. 972.8 divided by 4.7. Okay, that one gives me loads of decimals, so I'm probably going to just, leave it as a fraction. That one's the centimeters cubed. So then I could then work out, obviously, the total volume just by adding those. So volume of the total shape is obviously 32 plus this other one, which I'll just do on my calculator. I'm just trying not to round it too soon. That's why I'm keeping it as a fraction. So then again, that's a really horrible number, isn't it? So we'll just leave that. What's that? 11,232 over 47. Okay, fine. No, not over 45, over 47. Right, so then now the last thing is just making it into a percentage, isn't it? Percentage. So of the top divided by the bottom. The top divided by this one divided by the total, isn't it? So this 11,232 over 47. I've still got the answer in my calculator, so I'm just going to do 32 divided by answer. Just one answer, ideally. Now, let's see. Obviously, I then need to times that by 100, don't I? So that was my answer. Times it by 100 to make it into a percentage. And what they said, to 1 decimal place. So now I can round it. You see how now this is my final answer? So I can round that to 13.4. Times 100 to make it into a percentage. 13.4 is what I got. Don't know if I've gone slightly out there, but last question. This one actually I think was a little bit easier almost. It wasn't too difficult. Question 26. This one is, I think, 4 marks. Let me check. Yeah. 5 marks, that one actually. 5 marks. Okay, that's fine. So we've been given a regular heptagon. The area of triangle ABG is 30 centimeters squared. So this top bit here. Calculate the length of GB. So just that one. So they've created a triangle. Now, whenever they say regular something, so it's obviously like pentagon, hexagon, heptagon, you know, some kind of polygon, I'm thinking there's this formula, which I know this formula I think already came up in paper 1, but it is a formula that is not on the formula sheet, but it's really easy to use to find all of the angles in a heptagon, because you probably obviously haven't just memorized that. You would do n minus 2 times 180. That gives you the total. But if I want to work out just one angle, this one, let's say, because it's regular, they're all shared out equally, aren't they? So I can divide that then by n. So in this case, I'm going to do, in my calculator, 7 minus 2 times 180 over 7. Let's get my calculator up, because I think this is not a nice number. So effectively it's 5, isn't it? 5 times 180. So the total degrees in a heptagon is normally 900. Because it's regular heptagon, they share them out equally. So you can see it's not a great number, but I'll try and keep that in my calculator. 128.57-ish. 0.57-ish degrees, isn't it? That's what this one is. So what I'm going to do with that is, because if you know on your formula sheet, you have got the area of a triangle, but the trigonometric version. So that one is half AB sine C, which is obviously that angle there and the two sides between it. So what you could do, because it's a regular heptagon, I know that each of those sides are the same. It's an isosceles triangle as well, isn't it? I know that they're the same. So I could just use x, or you can use whatever you want. So I'm going to set up my equation. Half a times b, so x times x, obviously x squared, times sine of this angle, 128. Try and keep all your decimals in your calculator, but then that equals 30. So I've just created an equation, and the equation can help me work out the side length, can't it? That's the only thing that's missing. So to rearrange my equation, what I'm going to do is I'm going to do immediately sine of that answer, so I can keep all the decimals. That's that. Times it by a half, or divide by 2 is the same thing, isn't it? Divide by 2 is this, and then I would divide across. So 30 divided by my answer. I'm just doing it all in the calculator just because there's so many decimals. So that's x squared. So x squared is 76.74-ish. I'm just rearranging the equation, basically. Obviously now I'm going to square root that answer. Again, don't round it too soon, just keep it there. So we've got x is 8.76-ish. So each side length is 8.76. ... Now, this would calculate the length of GB. I'm just now focusing on the triangle again. Just think of it as it is a triangle. I think there's different ways you could do this, but I was just thinking cosine rule, because technically I know these two sides, I know the angle between them, and cosine rule helps me find the opposite side, doesn't it? So I'm just thinking to use cosine rule, which again is on your formula sheet, but I'll write it here. A squared plus b squared equals... a squared equals b squared plus c squared minus 2 bc cosine A. So because we're looking for a side, luckily it is in that order, isn't it? So we've got a squared is equal to, because b and c are the same in this case, aren't they? 8.76 squared plus the other 8.76 squared minus 2 times, again, 8.76 times the other 8.76. And then now this time it is cosine of the angle 128. Now what you can do if you want, because we've got two numbers here, the 8.76 and the 128.57, if you really want to keep the decimals, then they do give you a slight range of answers, because obviously it's quite hard to keep the decimals in a calculator, but you can store one of them as your answer if you want. So you do shift, this one that says STO, I don't know where it is on your calculator, it might be in the same place, it might be different. And then I would just choose like a letter. So I'm just choosing A. So that answer now is in A. I want to get my 128 back. So I probably should have just stored that earlier. Let's say if you stored that earlier, that would obviously be better, wouldn't it? Over 7. Nope. Over 7. There it is. So I'm now going to type in my cosine rule, but remember that in my case, I've put 8.76 as A. So I'm going to do alpha A, where's my squared, plus that one again, technically, isn't it? Minus 2 times the A again. I just like to be really specific with my decimals. You could probably just use 8.76 and it would probably still be within the answer they've given you. And then for my cosine, I'm using answer because my answer was the 128, wasn't it? Remember that? Got all of that. Yes, okay. Now, obviously, that's A squared, isn't it? I might just write that down for a bit of working out, 249-ish. And then I'm going to square root my answer, 15.78. Now, they've said to 3 significant figures. Now, because this is the final bit, then yes, I am going to just round it now. So 15.8 would be 3 significant figures, wouldn't it? So technically A is 15.8, but that was obviously the GB, wasn't it? The actual, like this line here. So yeah, 15.8 there. Yeah, it was a really long paper, this one. I guess because there was quite a lot of, I feel like 1 or 2 markers, maybe the ones where it said, find what was wrong. It was only like a 1 or 2 marker, wasn't it? There was quite a lot of those, so they ended up with more questions, but you might have found maybe the questions individually easier, I don't know. But yeah, it was this one for Edexcel, I think, is quite long. Normally, I feel like Edexcel is less than 25, isn't it? Somewhere between 20 and 25 questions. Obviously, who knows this year, because your paper 1 was only 17 questions. So who knows what they're going to do? I don't know. But yeah, quite a long paper, that one. Again, this is a November one. You're obviously doing the June ones. So I do feel like, I don't know, maybe it's just me. I feel like the November ones feel a little bit different for some reason. Maybe they are, maybe it's just in my head. I don't know. But yeah, that was the November 2022 paper 3. So I'm just going to do, in my live videos, we're doing paper 2 and paper 3 because obviously the topics don't really split between those very clearly. It can mix between each year, what comes up on paper 2, what comes up on paper 3. So if you're doing past papers, make sure you do both, paper 2 and paper 3, just because the topics are so mixed between them. It's not very obvious which is just paper 2, which is just paper 3. So that's why I'm going kind of through both of them. So tomorrow we have another one at 7 o'clock. If that suits you guys, you can obviously watch these later on anyway. They will upload automatically. Tomorrow's is November 2021, paper 2, just so you've got a heads up. And then obviously next week I'll do the paper 3, and then you can see what we're doing. We're working backwards in time because back in April I did go through the paper 2 and paper 3 of the first few, like June 2023, November 2023. The more recent ones, we did do those before the non-calculator. So if you want to watch through those ones, then feel free to go back through and find, I've got a playlist for lives. But yeah, we're working kind of back in time, so we'll be heading towards, 2017 from here, if that makes sense. So yeah, otherwise that is everything on this paper. Thanks for joining me today, guys. I hope you find it helpful, and otherwise, hopefully I'll see you tomorrow or in one of the other lives.